like on the computer. I don't know why this video wasn't good enough. But I didn't even get proper feedback. But okay, let me just quickly try. Cool. It's really not that tough. Let me. I actually spent last night trying to figure out how I'm gonna do this here. So let me just start a share and see now. Cool. Stop sharing and then I will. Okay, cool. Let me. Okay. Let me see. I'm looking for the question quickly, man. I wonder if I can place it there. Where is it? More stress. Is it T2 by equation and sessions in 5 more? Once you know how to do the circle, it's just need Sazi, your mic is
Yes, sir.
please mute the mic. I can't paste here, man, but let me try and share the whole screen then. So let's try and do this one. It's the first one in the which I think I tried to attempted to do. Maybe I should try and make a recording. You know, so you see this one? Can we all see this one?
Yes.
Okay. So really how simple this thing is just following the steps here, guys. It's really not that tough. In the end, the product must look like this. Okay. So what I'm going to do now, I'm going to try, I don't think I can, let me see if I can write on my board quickly here, or this one. Okay, cool, I can. So here we have our thing. So we take an element. There's a lot to say of how this is useful. There's really a lot to say on what's happening, but what this essentially is finding, it's like finding a resultant for forces, but it's the approach used for stresses. So yeah, you know, and we're taking an individual element over here within the thing and we're analyzing this. So it's 70, and then what's the other one? Where am I now? And it's 150. Okay, cool. Let me try my best. And currently there's no shear stress on here. Okay, so the first thing you want to do is obviously you want to find the center, right? Get a ruler, and then make an axis, make some kind of Cartesian plane.
Cartesian plane.
Yeah, it's really not that tough. I was going to use AutoCAD or SolidWorks, but it's just my work laptop is full. Cool. That's the first step, right? The second step is you want to choose a scale based on this here. So you can work full scale or half scale depending on how big the thing is. But I'm going to go with 1 MPa equals 1 millimeter. I hope that's easy for everyone to understand, right? Is it fine?
Yes.
Okay. So now, what you want to do is this. You're going to plot these stresses. I'm going to do it in a way that I'm going to also change a few things. And the last part of the question did I not put here is apparently we are at 30 degrees as of current now, right? So cool. What's key to always note, this direction is anti-clockwise, right? We all know this now. And this direction going that way is clockwise. Are you guys with me? Guys, talk to me. You know that, right? Measuring an angle. If I have an angle like here, you know what I mean? Somewhere over here. Okay, that's 45 degrees. But anyway, so the reason why I'm mentioning is that sometimes the element will not be anti-clockwise. So it's very important. So the first thing is you want to plot these things on here. So how we do this? I'm gonna choose a red pen, and you start from your center, right? That's gonna
Sorry,
be
sir. Sorry to bother, sir, but
yeah.
I can't see anything, sir.
Am I not sharing my screen?
I only
No,
see
sir.
the example 4.9, sir.
4 point?
I only see an
4.9.
example.
Okay. You guys should have said that a long time ago. Okay, let me just share. Yeah, can you see it now?
Yes.
Okay, cool. So I think let me use a half scale rather. So I'm realizing now I'm on the side of the thing. So let me go half scale, and I'm gonna say I'm gonna say 2 megapascals. Is that fine? So I'm doing my X first, that one, and if I go from this center, that should be around 75. Just make the line going this way. So I use red from there to there. That's 75. 75 is my stress in the X direction. Are you following me?
Yes, sir. Is it
Perfect.
supposed to be 75 or 70, sir?
150 divided by 2.
Oh, okay, sir. Okay.
I'm going with this scale over here, no? That's fine. So now I'm going to just provide another case. If this was given as, where's my razor? If this was given as like this, man, do you know what I mean? Compressed now, right? You guys with me? Talk to me, guys.
Yes.
If it was, I want to see what it does. Yeah, if it was given like this, that means I must draw it on this side now, the negative side. Are you with me? I'm just letting you guys, making you guys aware. You see what I'm saying? So you go 75 that way now. You guys got that? So positive this side, negative this side. Is it clear to everyone? I'm creating a hypothetical case just to teach you different variations as well. Okay, cool. So let me revert back. So the question was obviously in a tensile. So just redoing that again. So now we follow the same idea here, and we want to go with stress y, right? And that should be divided by 2 as well. We come to the center, and 70 divided by 2, I believe, is 35. Let me use blue. Is it fine? Like that? And that's stress y over there. You guys got that? Is that cool?
Yes, sir.
Huh?
Yes, sir.
Talk to me, guys. Yeah. And so then once that is done, I'm not sure. The next part is to find your center of your circle, right? Which is essentially your average stress, right? Which is not a very proper value. So I'll do it over here. And your average stress or center of the circle is kind of fairly obvious. We think it's going to be 150 plus 70 divided by 2. And remember, just be careful. If it's compressed, the signs must also take the same thing. Are you guys with me? So if it's compressed in this direction, there must be a negative 150 here. Are you guys with me? So that's 150 plus 70 divided by 2, and you should get 110. Okay. 110 megapascals. That'll be my center of my circle, no? So now, what I'm going to do now, I'm going to put my center, and 110 divided by 2, I believe, is 55. So that I'll make green. So that's around here. I mean, obviously, I have slight, differences. Okay. Let's make it here, maybe. Are we all on the same page now? Center of the circle. Oh, back. Okay. Are we all cool with that?
Yes, sir.
Yes, sir.
Okay. So once you have a center of your circle, now you got to plot Mohrs stress circle. And according to the book, they use like OP or QP, all that type of things. But the key is you wanna plot your circle. Where am I now? You want to plot your circle from the furthest point over there. But you notice it'll always be there'll be equal distances, man. So in this case, it's gonna be over here. Right? Let me show you. Got a cute protractor over here. So is my 75 at that line? I'm just make sure. So I'm going to put that in that center. There won't be slight differences. Just going to move my compass to there. Okay. Roughly there, right? Is that cool?
Yes, sir.
Yeah, cool. And I'll sketch. Now it seems a bit simple on the computer, but you know, if you're not used to a compass for a while, let me just redo this. I said I want purple. I was not give me that color. Why am I still yellow? Let me just check. Okay, let me just click that again. Bring it over here. I'm still on yellow, red. Okay, the software is not smart enough. Okay, let me just choose that color. No. Am I colorblind or what? Okay, cool. So give or take there, right? So just try to be as accurate as possible. I'm trying my best here. Let me just slightly adjust the somewhere there. Okay. So now you sketch your circle from that furthest point. Like that, you're closing. Done. Once that is done, you take your compass away. And then what is next is this 30 degrees, right? Now, to find your angle, you got to make always sure you got to times it by 2, right? So that's explained well with the theory, actually. So always remember your angle, 2 times theta. Why are you, is this colors not? So let me just go blue again. 2 theta, and 2 theta will be 60. So whatever the angle they give you, always make sure you multiply it by 2. Is that cool with everyone? Whatever angle.
Yes.
Okay. That's
Yes, yes, sir.
there's a theoretical reason for that. So it's not well articulated in the book. So if you're anti-clockwise, we're measuring this way, right? So what it means is that the angle must go from here to there somewhere, right? And then we're going to draw a line. So if it was clockwise, you'd start there and measure downwards, something like that. Is that clear to everyone? If it was clockwise stated in the question. Anti-clockwise, you measure from there. I'm sorry about that. I'm just going to undo. Oh, I can't undo here. Let me just erase. If it was anti-clockwise, you want to start from here and then measure up 60 degrees. Are you guys with me? Anti-clockwise. You see there? So clockwise is down, anti-clockwise is that way. So now let me plot that 60 degrees now. I'm not sure if you guys will be able to see my protractor. Share screen here. Screen, okay. Normally takes more bandwidth. Okay, cool. Where's my? Okay, cool. Can you guys see my protractor over here? I can't use a protractor on this one. Okay, cool. So I'm gonna put it over here, and I'm gonna check where 60 degrees is. Colleagues, are we all still here? So that's more.
Yes.
So
Yes, sir.
So take a protractor, 60 degrees is somewhere over here. Let me just check. Let me just erase this thing here. Erase that there. Clarity. So from that center point where you found your center of your circle, now you're gonna put where 60 degrees. 60 degrees is somewhere there. Somewhere there, right? Just somewhere there. Slightly off, somewhere there. Okay. Cool. So you want to put obviously 60 degrees from that center. You do that. Once that is done, I will close this. You take your ruler and you'll be drawing a line. Oh, I'll just go with red. So take your ruler, you've marked that point off. Come over there. And I think it's that my pen is a bit fine. Obviously there'll be okay. I don't need to go all the way, but you get the idea, right? So I'm slightly off there, but that's okay. So that's 60 degrees at that point here, right? So you don't actually need all of this here. You don't need that piece though. But anyway, that's fine. Once that is done, colleagues, right? You then take another line from that original center, right? And you're gonna make a line from the point of where it touches the circle to that. This will be a resultant stress of those two, just like in forces. So when it comes something like that, I'll take my, let's go this color. I draw a line like this. That there is my resultant stress. Okay, cool. And my resultant angle will be, let me remove my pen. Let me remove this. This over here is your resultant stress. This over here will be your resultant angle. That's the stuff they normally want. And then the last one is your shear stress, which is the line from. Guys, is this helpful? You guys are saying nothing, man. I know you're watching me here. That's a bit of an issue for me, but
100%, sir.
okay, perfect. I'm glad as long as it's helping. That here is your shear stress, just over there. Ooh. Let's do that again. Yeah, just there. So let me just clean. So you know the question will normally ask you those things like what is your shear and all of that. So then once that is done, all you gotta do is a measure. So let me measure the resultant quickly for you. So take your ruler again now. Once you've done that, start at 0. Obviously, I'll be slightly off. My thing's a bit not as clean here. That's around 60 what?
68.
68, perfect, right? So we know that's 68 millimeters. Let me just remove this. So we know our resultant is around 68. I think Mr. Moses is liking this. And obviously, based on that, we know we must just times by 2, right? 68 times 2, using my calculator here, is 136 megapascals. Cool, right? Let me measure my shear stress as well. And then, shear stress. So you're going to measure that line over here from here to here. How much is that there? Around 19, eh? Give or take 19, 18, 18.5. What do you say?
18.5, sir.
Yeah, 18.5. You can call it 19, 18.5. The angle, 18.5 degrees, right? So that's linked. Right? So it's 136 degrees at 18.5 degrees. And then obviously we want to measure our angle, our resultant angle. So I just want to open my protractor. If I paid for the full one, I could have used those things there, but I had to be smart and get another software to measure angles. Yeah, okay, cool. So we take the protractor, we put him flat there, and we check that angle over here. And what am I reading off there? 16 degrees, right? Can you guys see it? 16, huh? 16.05. Yes. Cool. Oh, this is, sorry, my bad. So that's 16.05. I got it. Don't worry. 16.05. Just to close. So this is 16.05, the angle. 16.05 degrees at the angle. That's linked. And the shear was what again? What is my shear again? 18. What is it? What, was that 18? Huh?
18. 18.6.
Yeah, 18.5. 18 point, no, minus 0.5. Okay, 0.6. But then we must times it by 2, right? That's millimeters. So that's around 37 megapascals. So there you got that, there you got that, there you got that. That's your average stress. You basically got everything. Let's go to the question. And what do we get? We got 130, our average is 110. We've got 135. Let me check here. Quite close, say 136. Got 16.65. That's very good. And our shear is at 37, close to 35. So yeah, we're basically done. Yeah, there we go. Our normal stress is, what is our normal stress again? So what's my normal? R to S. R to S. That's something which I'm not. Yeah. So normal stress. Oh, it's the stress normal to the that's over here. So the normal stress basically is measured from. Let me just do that as well while I'm here. That's normal to the element, which is this thing over here. So we at least have a recording for this. Normals from there to this part here at the bottom. So let me just make another thing over here and just say over here from here to here. I've got to fly my face. Yeah, just go that one. Normals from there to there. And that's around 60, give or take like 65, 67, right? So just put that away. Your normal stress is 67 millimeters. Therefore, on double scale, that's a 14 plus or a 20. Which is 130, what's it? 134 megapascals. And if you look at the equation, am I missing something? That's R2S. Yeah, oh, they made a mistake. Yeah, it's supposed to be 130. Yeah, it's a mistake. It's 130. So it's 130 megapascals, and I got what? What did I get again? 134. Yeah. So you're all allowed to be slightly out, obviously, because tools have their own inherent uncertainties depending on your divisions of stuff. But as long as you're within proximity. Any questions, guys? What is helpful? I hope you guys learned something.
Baie dankie, sir.
Yeah. Did you see the procedure? You sure?
Thank you, sir. You open the gates for us. We can see now.
Okay.
It's much
Thank
better
you.
right now. Yeah.
Okay. It's not tough. Can you see? So if you do this one, I just want to show you quickly. I just want to paste him somewhere. I can't paste him. Well, let me just draw the element for you. The thing is, it's a bit okay. It's still a bit of work when I'm doing it here, but like with tools, it's also getting used to compass, and so this one is -70. So it's or not. You don't have to put negative, but it's 70 MPa. It tells you negative is being compressed. There is a way to verify all your answers with a formula as well. Just by the way. What is this thing? Another one is 150. Okay. So this is also another case where you just got to get used to all the cases. And then it's good when I have time, I can focus on doing all the cool stuff. And this one's also 30 degrees anti-clockwise. So just remember when it's clockwise, you gotta come this side. Are you guys with me? Then you pull your resultant from here. Are you guys with me? You guys got that? If it was a clockwise type of yeah. So you won't pull it from that side. I'm just making you aware. So always be cautious of that. Let me just say back. Okay, it's back. Oh, anyway, let me just erase it. Like it's working better. So in this case, I'll do this. I'm not gonna do the whole thing. I'll just do it like with freehand quickly, like a line there, a line there, and that whole thing's on Google Classroom. So if you do like 1 or 2 of them or 3 of them, and then just go straight to the past papers and practice, so you should be fine. So this one, you'll say from here to here is like, let's say that's 150, whatever scale you have. So that's 150 megapascals. There's X. But for this one, can you see it's negative 70 now, right? Because it's being compressed, right? Arrows are together. So you start over here and then you must come over here now. So that's negative 70. You guys got that? MPa. Can you see what I'm talking about?
Yes.
The notation. Are you there? And then your average stress, which is the center of the circle, will be 150 minus 70 divided by 2, right? That'll be 40. And 40 obviously be somewhere here. You know what I mean? You guys with me? Talk to
Yes.
me. Yeah, and then from there, from that point, you can go on that point in your circle, come up something like that. You know what I mean?
Yes.
And from there, you must get your element at 60 degrees, whatever. And then you want to measure from there, something like that. Then your angle will be there. Okay. It'll look something like, you see there, something like that. I hope you get a rough idea. Yeah. All right, guys. I'm glad I did that. Yeah, especially if you guys found it, but it's not difficult, man. Yeah. Is there any other questions before we depart?
Nou, baie dankie, sir. Baie dankie.
Okay. Yeah. So go over the second moment. Question: Do at least 2 or 3 of them. In parallel to that, do Mohrs test. Practice this immediately. It's really not that tough. I promise you, it's 3 marks. Yeah. And all what is required, the main things are, in the end, is your shear stress, your resultant, its respective angle, and your normal stress. I think that's how they typically ask. And you're all allowed to have a certain tolerance out there. Okay, guys. All the best, man. Cheers.
Azi, dankie, sir.
Yes,
Thank you, sir.
Thank
you, sir. Thank you.
Thank you, sir.